This is the series of design pattern. Let's see the second category of design pattern, that is structural design pattern. Structural design pattern focus on how the class and object are composed to form the large object. It helps in case you wanted to assemble or communicate between the two different objects. In that case, you if you follow this structural design pattern, then your code will be very much organized and it reduces the complexity and also help in improving the scalability of the program whenever you want to scale in later. In simple word, we can say it defines how the objects are connected or structured. So there are different types of structure design pattern. Let's see one by one. First is adapter pattern. It makes incompatible things work together. Let's understand with example. Consider you have your old charger and which support the USB type port, but now you wanted to charge your mobile phone which having the C type port. For that you can use one adapter and you can insert the port, and then you can change your USB port to type C and you can utilize it for charging. Similarly, we have wrote the code like that. There is one adapter class and we have old charger. If I run it, I will see the output charging with USB. Means it's saying that you are charging with your old charger, but actually you are charging your type C port phone. Let's see the second one, which is bridge pattern. It separates the abstraction from implementation. Let's understand this with also example. Consider you have your TV and projector, and you might have seen that you can operate your TV and projector with a single remote. It's similar like that. There are two implementation, which is TV and projector, and now you are controlling these two things like turning on, turning off your TV or projector with your single remote. So similarly, we have created these two classes for TV and projector and one for remote. If I run this program, I can show you with the single remote I can operate TV also and I can operate projector also. Let's see the third type, that which is composite pattern. It's nothing but a tree structure. Whenever you write your program, you need to follow some structure like one main branch and it's followed by the sub branch. Similarly like that, we follow this pattern. You can see with one example, we have one folder structure and inside we have some files, and later on we can also have subfolder inside the folder and then subfile inside the subfolder. Let's run to see the output. See, I have added two files inside the folder and I can see that two files got printed. Let's see the fourth one, which is very much famous in Python programming also, which is decorator pattern. It allows to add behavioral dynamically. Consider you have one program, you wanted to have program for adding two numbers. Later on you thought that why not to add some validation to that program or also some adding some logging to that program. At that time you don't want to interact or don't want to modify the existing code so that it will break let anywhere wherever you are using. In that case you can utilize this decorator pattern and add that decorator in such a way you can modify your program from anywhere. Here we can see earlier we had this add function which allowed to add only two number. Later on we have added decorator at the rate smart. This is the syntax of the decorator. Inside the wrapper we define what decorator we want to add to that addition function. We want to do the validation and so we want to add the logging function. So if I run this, I will get all the information. I have printing addition of 9 and plus string. So first it's throwing me error, please provide the number only, and it also doing the logging, and at the last it giving me the output of the 18 line number which is 15. Let's see the fifth type of design pattern, which is facade design pattern. It simplifies the complex system and hide the complexity behind the simple interface. This example we have seen in many places, like we use our WhatsApp to communicate. We don't care about how the message sending from our device going to the other device. We just care about the text and we enter and we click on the send button. Similarly, we have our phone, we have our computer. In computer also, whenever we turn on our computer, there is a CPU which started, there is a memory which getting loaded, which we won't care. It's just like that. Let's run this code, which is very much similar. See, I have created one class for computer faucet, but it whenever it started, it create one run an internal interface for CPU and another interface for memory. So we have one simple interface for computer, but internally it has many complex interface which run behind it. Let's see the sixth type, which is flyweight pattern. It's the helps to save the memory by sharing the object. Mm, just it's reusing the common data. Consider we are playing one game. uh, for example, there is a contra game which is based on the soldier. So in that contra game it has a gun, and consider there are so many uh, player who is playing, and there are so many soldier are there, and each one has their one weapon which is gun. Whenever the programmer creates his program, they need to allocating some memory for any object they created and with the data. So in order to reduce the usage of memory, we can utilize this design pattern. Based on the data, it will only allocate the one object. If we take some other data, then it will create new object, otherwise it won't create. That helps to reduce so many memory space in case of this kind of gaming application. Similarly, we have taken this example. Here we have created one soldier, and in that case soldier having one weapon, that is gun, and we have created two separate objects, but whenever we run it, it will allocate only one memory space for it. You can see it's sent true, means we have created only one memory space. If we pass any other data, which is let's say grenade, and we will try to run, then it will occupy the some other memory space. Now we will get false in this case. So likewise, it is very much similar to the singleton design pattern, but only difference is that in singleton pattern we allow to create only one object, but here it's a condition. We can create multiple object, but it allow only when we have a different data as an input. Let's see the seventh one, proxy pattern. It controls the access to an object. It provides the authentication, helping the adding security, caching, and logging. Let's understand with an example. Consider there is a banking application. There are many banking applications which providing the login for the user by passing their username and password. Consider any banking application wanted to add additional security, like they wanted to user to pass user OTP along with the password. So they can utilize this mechanism to enable the user for passing the OTP along with the username and password. So there is a banking application, and they have added one proxy along to it. While requesting for accessing the application, first it will go through the proxy, and then it provide the actual access to the login application. Let's run it and see. First it check the access, whether the user has access or not, by passing the OTP, and then after it allows to log into your banking application. Let's summarize each type of structure design pattern in one line. First, adapter. Make two incompatible class work together. For example, we have our old charger and which is of USB type, and we have our phone which support port type C. In order to convert, utilize both the things, we are using adapter which convert port USB to type C. Second, bridge. Separate abstraction from implementation. For example, we have our remote which operate both TVs and projector. Third, composite. For example, we are storing the folder inside the we have some files, and inside also we can have some folders or files. Fourth, decorator. Example is addition function. Earlier we had only addition of two number. Later on we added validation along with some logging functionality. Fifth one, Facade. Provide simple interface to complex system. Example is your computer system. You have your CPUs on memory loading, which is internal complex interface. Sixth one is Flyweight, which is saving memory by sharing object. We have seen the gaming application from the Contra. We have the soldier there which has a weapon gun. For that, if you have multiple 100 or 10,000 uh, soldier which have gun, then only one memory space is utilized. Seventh one, proxy, adding the extra additional security. We have seen in the banking application, instead of only using user login, it allows to ask user for OTP. Thank you.